Hello, friends. Welcome back to Brave Effects program, Insight Fellowship program in Advanced Analytical Problem Solving Expertise, and we are in the middle of Six Sigma Green Belt. So, in our previous videos or series of videos, we have covered the define phase, measure phase, and analyze phase as well. A strategy one of analyze phase, to be precise. Um, Today, in today's video, we're going to look into how are we going to use statistical testing for strategy two. Now, strategy two is when senior management, because of certain reasons, are not allowing to collect data, for a 1 month of it, maybe because of the urgency of solving given problem, right? So how should we go ahead and have a data which is needed to deploy a statistical test? So let's go to next slides and try and understand how we're going to do it. And of course, we are also going to take a live example the way we kept on taking. That's a pattern for us, right? So I'm going to show you a live as well how to deploy it in our statistical tool. So when I'm going to say in our statistical tool, it's R means yours and mine, right? Because we are one family now, right? So you can use that tool. But yes, before we proceed, let's recap. That's what we kept on doing. So let's go to next slide and quickly recap what we covered till the date. Next slide, please. Right. So we started with define phase. In define phase, we first of all prioritize the problem, then we quantify the problem, then quantification of the problem, then next thing all we did is like we checked out where exactly a given problem is located. Once that is done, we enter into measure phase with the help of performance standard. We somehow define how are we going to measure the problem. So we provided that measurable characteristics to the problem. And then our, sequential activities, finding out the probable causes, then converting those probable causes into critical causes, and from critical causes to statistically significant causes. So when we started in one of in our example of PT non-compliance, we started with 21 probable causes, and we have seen that somehow we extracted three statistically significant causes. So it is much easier, less costlier, and more effective to work on three most significant causes out of 21 causes. Right? So that's how we do it, and that's what the power of major phase. That's what the power of Six Sigma. And another thing, what we did in major phase is also we try to find out how deep is the problem with the help of capability analysis. Right, so that's a define phase, major phase. In analyze phase, we use chi-square testing and hypothesis testing, to find out statistically prioritize significant few causes from critical many causes. So that's what we did with the help of chi-square and goodness of fit test, graphical analysis. So not a complete goodness of fit test, a graphical assessment of goodness of fit test. So that's what we did in a series of videos previously. Now let's go and try and understand how are we going to deploy strategy number two over here. So we're talking about strategy number two. Let's go to next slide. Right, so analyze phase strategy number two. It's not analyze strategy, analyze phase strategy number two. Let's go to next slide. Right, so this is what we know. This is the kind of we have a defect density non-compliance. So this is another example, right? For our PT non-compliance, of course, we collected 1 month data. We'll continue with that as well. If you could remember, this is an exercise, right? So you either can learn it right now, or maybe, you can learn it during the analyze phase, or maybe once you're done with the DMAT, you can learn this annexers as well. So this is another example where we are going to check what if our senior management is not allowing us to collect data, how we're going to do the statistical analysis. And for that sake, this is a second example, defect density non-compliance. This is another internship project where we have shown you how to deploy statistical assessment when we are not going to collect the data. So this is just an example. I'm showing it right now. You can also practice the same project of defect density non-compliance in internship projects. So defect density non-compliances are why, and we have 8 different categorical X means are causes, and this is just a coincidence that we do have 8 causes the way we had 8 causes into our previous project, that is a PT non-compliance, that as strategy number 1 there also we had 8 causes. So are we supposed to always are we always going to have 8 causes every single time, which we can select it through critical we can select through CI matrix? Not necessarily. We can have nine causes, we can have 7 causes, we can have 6 causes, we can have 8 causes. Even we can have more than 9 causes. All we need to do when we are going to have more than 9 causes, say take an example, we have 11 causes. So now we let's take an example. So for probable we listed out say 30 different probable causes, right? Just a hypothetical case. And out of these 30 different probable causes, we somehow selected 11 highly controllable, highly impactable causes. So those are relatively higher number than 9 causes, which we need to take. Now, what to do in that case when we had 11 causes? All we're supposed to do is we need to ask participants to choose most critical 9 causes from the list of 11 critical causes. So let me repeat this sentence. So we have to request participants who are there in a brainstorming session, just ask them to select most critical 9 causes out of these 11 critical causes. So they can do it either through majority, where majority of them think these are the 9 most important causes, or they can have a consensus as well. So, okay, these are the 9 most significant causes. So you got to have that segregation between most critical and critical. If we have more than 9 critical causes which we found or which we segregated from CI matrix, right? So please be clear about that. We can take, or we need to choose 9 critical causes from CI matrix, right? So here also we have 8 different causes. Statistical inferential test, same chi-square test, and advanced post hoc. This is called post hoc test. Post hoc test is like extension of your statistical test, kind of an advanced thing. But here we are going to use only graphical analysis of chi-square goodness of fit. Let's go to next slide. Same, we got to put the hypothesis. Our hypothesis is one or few of the prioritized causes from CI matrix have statistically significant impact on defect density non-compliance. Right. In our previous project, it was PT non-compliance. Here, defect density non-compliance. Hypothesis RH naught, that is null hypothesis, is critical X's that segregated or prioritized from CI matrix have no impact on defect density non-compliance. Versus our HA, that is alternative hypothesis, is one or few critical X's or critical causes that segregated or prioritized from CI matrix have statistically significant impact on defect density non-compliance. This is the ultimate thing you want to do, right? This is what you want to find it out. So let's go to next slides and try and understand how we're going to testify it. Right, so we are here to collect the data in strategy number 2. And if you could recall, we said that, when we had 5 members in that brainstorming session, we also requested to add up additional 5 members, right? And then manager, brought in additional 5 members. Now we had 10 members team, if you could recall, major phase. While talking about strategy 2, we discussed about all these things, right? So now we have 10 different participants, and in brainstorming sessions we had 8 different causes, cause 1 to cause 8, right? And now all we're going to do is we're going to ask each of the member in a brainstorming session, member 1, member 2, up to member 10, right? We had 5 members previously, and then we added 6 to 10 members, right? Additional 5 members. And of course, prior to coming to this exercise, we also sensitize them with the problem and different causes we found, so that they get sensitized with what is happening, in our brainstorming sessions. So now we have a team of 10 members, and we ask each of the members to rank these 8 different causes, but rank individually without taking help of any other members, right? So it's not with consensus, or it's not with discussion. They have to individually rank it. So there is a possibility that there is a differences in between their rankings, right? There's definitely a possibility of it. But all the system is going to do over here is going to see the pattern that out of these 10 members, how many members gave almost consistent ranking to given cause, right? That's what we really want to achieve, and that is why we want people, or we want participants to individually rank the given causes. Once that is done, of course, we'll give them a sheet of paper where they'll just put it over there, right? Then we collect it together, we type it in a spreadsheet, and this will look like this. So 8 causes, cause 1 to cause 8. Member 1 gave this ranking to all these 8 causes. Member 2 gave this ranking, and likewise all of them gave the rankings, and we collated it in a spreadsheet, right? This is what we have it. So copy data only from the amber colored cells and paste it in a team breaks chi-square tool. Simple. Now all we need to do is we need to copy all this data, right, into our chi-square tool. So let's go to next slide. Next slide, please. Right, so this is how it will look. Now this is a different version of our chi-square tool. This is for ranking based assessment, and previously was based on the ratings, right, for 1 month's data. So this is bit different, but here we are going to paste that data. So you could see individual 1 to individual 10, cause 1 to cause 8. This is the title of cause 9, where we don't have anything over here. It's a blank. So we're going to remove this C9. Right? So important. If there are 8 causes to be tested, remove title of C9 from the system, which we did in our previous version as well, or previous system as well of chi-square. We also need to put number of causes over here. And once that is done, once we tested the data over here, and once we remove this C9 over here, automatically we're going to get p-value, and we're going to check the p-value. Right now it is 0.00. And we're also going to see the graph, that observed value versus expected value. So this is about graph of observed value versus expected value from chi-square goodness of fit test. So let me repeat. 8 thing all we need to do is add number of causes. We added it over here, 8. As highlighted, paste data of ranking of causes. So we did it over here. Then we remove this additional title of the cause, and then we check the p-value, and we also check the graph. As simple as that. That's it. So let's go to next slide and check it. Right. So here we could see inference. Since p-value is 0.0000, this is the p-value, we can infer that one or few causes from the list of prioritized excess have statistically significant impact upon defect density non-compliance. So we have proven our alternative hypothesis that one or few of the causes are definitely going to have statistically significant impact upon our Y. And in this project, the Y is defect density non-compliance. But we are not yet sure which causes, or which cause for that matter, do have a statistically significant impact on ROI. And for that sake, we'll use this graphical assessment. So here we can see the bar of observed value versus bar of expected value. And as we all know, if wherever bar of observed value is taller than a bar of expected value, that given cause is the culprit, for that matter. That given cause to have a statistically significant impact upon y. So here in this project, or in this case study, we do have C1, C2, and C5, which do have a relatively taller bar for bar for observed value than that for expected value, right? So here let's conclude. We can also see that observed value, this is the observed value in black color, and that is why it is indicated or highlighted in a black color, is higher than expected value, that is in a gray color, for C1, C2, and C5. Hence, we can extend our conclusion that critical causes C1, C2, and C5 from CI matrix have statistically significant impact on defect density non-compliance. That's it. We are done. So we found three causes over here as well. So in defect density project, I don't remember right now, but imagine had we came up with say 15 to 18 different probable causes, out of which CI matrix help us to prioritize 8 causes, and out of 8 causes, statistical assessment help us to prioritize 3 causes. So when we started with 18 causes, now we had 3 causes. In PT non-compliance, we started with 21 causes, and now we had 3 causes, who were statistically significant, right? So that's the power of Six Sigma prioritization based on statistical foundation, and when it is based on statistical foundation, it is more accurate than any decision based on opinions or intuitions only. So had we stopped at CI matrix, that would have been a good decision, but that would not have been as accurate as statistical analysis based decision making. That's the power, and that's where, as I kept on saying, Six Sigma is one of the most powerful analytical problem solving skill sets, which you are building the expertise in. So on that note, let's go to the next slide, please. Result of chi-square test and goodness of fit test. If you could recall, we had a similar table while we did executed statistical test for PT non-compliances in our first strategy. Now for the second strategy, we're going to have a similar table, right? So here, why it's defect density non-compliance in this particular case, we have 8 different critical causes which we segregated from that of CI matrix. Now CI or chi-square test p-value here, it was 0.00. Of course, we're going to see it in a live example as well. When it is 0.00, it nowhere means that it is exact zero. It's like a 0.0000 some number. So it's quite the minimum, but that risk is certainly there. Risk of what? Risk of rejecting null hypothesis. In other words, risk of accepting alternate hypothesis. Right? That's what we're talking about. And our alternate hypothesis is what? Our alternate hypothesis is one or few of the causes from the CI matrix, or one or few of the critical causes from the CI matrix have statistically significant impact upon our Y. That's what we wanted to prove. So here we have proven that, right? But with the help of graphical analysis of chi-square goodness of fit test, we extended our analysis to conclude that these X's do have statistically significant impact out of the list of critical X's. So which are those X's? Here we could find C1, C2, and C5 are the X's where observed value is higher than expected value. In that graph, if you could recall, for this particular X, the bar of observed value is, or that black colored bar is taller than the gray colored bar of the expected value, and that is why C1, that is requirements overlooked due to negligence, this particular cause is significant, statistically significant X that need to be fixed with appropriate solutions. And same thing applies to C1, C2, and C5. But in case of other causes, the observed value is smaller than expected value. In other words, that black colored bar is shorter than gray colored bar for this excess. C3, C4, C6, C7, and C8. So these X's are not statistically significant, or in other words, they do not have statistically significant impact on Y, and that Y is defect density non-conforming. So this is kind of a summary table. So as I told you, let's take a live example, a live case, the same case, and do it on our own so that you'll have a better understanding. So let's go to the spreadsheet for further understanding. Right. So let's copy paste this data. We are going to copy this data over here and from here, and then we are going to paste it in our system over here. Right? So this is a second version. Okay. So here we're going to copy our data. We copied this data, and then we are pasting in a second version over here. That's the second version we had. A previous version of chi-square test was for that for strategy number 1, where we collected 1 month's data. So we had it over here. We are going to remove this C9. So I'm going to just backspace over here. I'm going to add 8 over here, right? And once I added 8 causes, when I removed this C9, and now we had 8 causes and 10 individuals gave the ranking. I put the ranking of tested ranking over here. I got a p-value of 0.000. And also the graph of observed value versus expected value. So here I could see that for C1, C2, and C5, that black colored bar, that is observed value, is higher than your expected value. In other words, C1, C2, and C5 are statistically significant X's, or they do have statistically significant impact upon Y. So that's about ranking-based statistical assessment analysis which we carried out. So let's go back to the presentation. Right. So here we were, and we took that example as well. Now let's go to next slide. Right. So we are almost done with the analyze phase as well. We started with define phase, then measure phase, then analyze phase. In analyze phase, we had 2 pathways, one for strategy 1 and another one for strategy 2. So we completed that. And now in next upcoming video, we're going to start the improve phase. Now what improve is all about? Improve is all about finding the probable and potential solution and check out whether those solutions do have impact on the overall performance of the project Y. That's what we are going to look into in improve phase. However, in upcoming video, we're going to check out listing out probable solutions to fix the problem, then selecting potential solutions from list of probable solutions, then develop solution implementation plan, and testing the solution by implementing them on a short-term basis. This is what we are going to look into, and of course, we're going to have certain tools as well, or templates as well there. So this is what we're going to look into upcoming video. So on that particular note, well, this is what we had in this video. Thank you so very much for your time. And as I kept on requesting, this is our initiative to build our nation, for that matter. So please help us to reach out to as many of you, your friends, your relatives, your neighbors, and that will be great. Let them know about this Breath of X program so that they'll also get benefited. When each and every one of you will get benefited out of you, then only this nation will get benefited out of it, and that's what we want to do. We just want to serve this nation. So on that note, Uttishta Bharata, Ma Bharati shall rise again in a full glory. So please like the video, share it, and if you have not subscribed it yet, please subscribe our YouTube channel of Great Effects. So on that note, let's go ahead and thank technology companies. We deeply appreciate following technology companies for their technological support. Thank you so very much for your time. Let's meet up in our next video. Thanks a lot.